Hey everybody, this is our topic presentation. My name is Shirong Bai.
And my name is Sorayya Niazi.
Our topic is about the criticisms of object-oriented design patterns. So our topic is divided by two parts. First, we're going to go over the very general criticisms of design patterns. Second, we're going to use some examples to explain what we mean by saying the criticisms of design patterns.
So the first and the big criticism against design patterns is about how much generic many design patterns are. That means anything can be considered a pattern, and often is.
And some design patterns do not really fit 100% into the work we want to do. So in that case, it might be very hard to use design patterns in that specific problem.
And most design patterns boil down the programming to interfaces. As you see, we use much interface for almost in all design patterns.
In some cases, design patterns add complexity to the work. For example, if we have a very simple problem, simple project, we don't even need any design patterns. But if we force ourselves to use design patterns, that will make our job more complicated.
So here is the strategy pattern. And the strategy pattern, the definition of the strategy pattern is to use to create an interchangeable family of algorithms from which the required process is chosen at runtime. So in the strategy pattern, we encapsulate each algorithm, and the strategy lets the algorithm vary independently from the clients that use it, and also it captures the abstraction in an interface, but vary implementation details in derived classes. And also the strategy pattern is kind of a behavioral pattern, and also it's the object behavioral pattern. So it means that it focuses on the relationship between the objects. So as we see here on the diagram of the strategy pattern, we have one abstract class, taxation, and we have the get tax method, and these are the children classes, but these are concrete, US tax and Canadian tax. Even you can see here at this code that we have abstract class taxation. We have get tax method that is abstract, and the Canadian tax extends this abstract taxation class, and also the US tax will extends this taxation. But we have the sales order class here, so we will in the strategy pattern we'll try to use the aggregation. So aggregation means we will use the object of one class into the other class to call out the child classes. So here we have the public class sales order, and we will create the object of taxation, and also we have the public class task controller. At this class we will create two objects, one for taxation, one for sales order, in order to choose which kind of tax we are using, which of these concrete child classes, children classes we are using. So so as you see, we prefer the aggregation instead of inheritance in this strategy. Even if you look at this diagram, it's very clear here that we should use the object of a strategy here in other class, and you can see that how this we'll use the aggregation, that is the sign of aggregation. We will use the aggregation here. So let's see what are the criticisms of strategy pattern. The application must be aware of all the strategies to select the right one for the right situation, and the application configures the context with the required strategy object. Therefore, the application needs to create and maintain two objects in place of one. And a strategy base class must expose interface for all the required behaviors which some concrete strategy class might not implement. So as you see here in this diagram, that it's clear that the interface, whatever method interface has, these concrete classes should use that. Maybe we don't need some of those methods in those child classes, but these children classes have to implement that method. And also the strategy and the context class might be tightly coupled. So that's it. So here is the second example, the template pattern. And template pattern defines the skeleton of an algorithm in a method, differing some steps to subclasses. So template method lets the subclasses redefine certain steps of an algorithm without changing the algorithm's structure. So also we have the one famous principle that says that don't call us, we will call you. This means that the low-level components are activated by high-level components. As you see here, the low-level means the child class and the high-level means the superclass. So our low-level components will be activated according to the by our superclass, or here that is the abstract class. So let's see what is the template method in more detail. So from the diagram you can see that we have an abstract class, and also we have the template method that is a method, but also the method contains some other operations. It can be the it contains some methods, so the methods can be abstract, as you see the code here. The methods can be abstract or can be concrete. So if those are abstract, the child class have to implement that. If those are the concrete methods, so the child class can override them or overridden it or not. But we say that the concrete operations are hooks. So what are the hooks? Hooks are the methods that can be overridden by subclasses. So this is optional, but as opposed to the abstract methods which are required to be overridden. So, and also in this code, as you can see, we have one final method. The template method is final. Final means that the subclasses cannot change the algorithm. So yeah, so let's see here we also have other diagram that shows the template method. So here it's a little more explanatory. We have a do query method, contains a format connect and also format select method. That are these children classes or concrete classes will implement these two methods, but each one implement different scenario which related to the these classes. This is related to the Oracle and this is related to the SQL. So, but both these children classes have to implement all of the methods that we have inside of the dquery method. But we will call this dquery method inside of the other class called query control to call one of these children classes. So let's see what are the criticisms of template pattern. So the first criticism that we can say about the template pattern is that it's difficult to compose functionality. When inheritance is used as a way to add a new functionality, it becomes impossible to add functionality in more than one access at the same time without defining more and more classes, as you can see here. So we cannot add in more access. So also the other criticism about the template pattern is that they are difficult to maintain. So this kind of system can rapidly become fragile. So the changes it means that the changes at any one level can disturb operation above or below that level in the template methods. And the other criticism about the template method is that they are difficult to comprehend the program flow. As you can see, we have the children classes should implement all of these methods. So, but we call them just the dquery method in other class to use these children classes. So understanding the workflow is a little hard. And also the other criticism about the template pattern is that it restricts you to a single inheritance like in Java. And however, overriding the parent functionality violates the encapsulation. So by encapsulation we want to hide the implementation, but if we override some of the methods in parent class, some of methods of parent class into the child class, so we violate the encapsulation. And also the syntax is complex, and it needs a little analysis to find out what is the overall of the syntax of the pattern is. And also it's a little complicated for the compiler to parse, which means that the compilation time will increase. Okay, so here is another example called singleton pattern. So this is the diagram how the singleton pattern looks like. We have one instance, the static, and a static instance. Also we have one static public method that we will use this method, the getInstance method, to call our instance and also or initialize our object here by using the private constructor. So if you look at this code, we have class, the private instance, we have the private constructor. So we will use the getInstance that is a static to instantiate our object, and also by using the private constructor. And so the singleton pattern ensures that only one instance of a class is created and provides the global point of access to the object. And the singleton pattern is a kind of lazy initialization, and it ensures that the singleton instance is created only when it is needed. So, and as I said, we use the getInstance method to call the singleton instance for the first time. So let's see what are the criticism of the singleton pattern. Singleton pattern, it brings the global access to singleton object, so this is a very bad design practice, and it has having the global feature lead to the increasing the chances of the tightly coupled code that will be difficult to reuse or modify or debug, and there is no public constructor, so it cannot instantiate directly, and the maintaining code is hard. It also makes it hard to unit test because it's not possible to isolate a part of your program, and a static method calls a static coupling. It means compile time coupling. So the singleton is the prime example of this kind of coupling, and there can only be one instance, which is so the single most feature of this pattern, but it's an inhibiting feature when more than one instance is required. For example, if more than one logger is needed, and logger mechanism is implemented through singleton.
Another example is iterator pattern. So the definition of iterator pattern is it provides a way to access the elements of an object sequentially without exposing its underlying representation. So first, the iterator is a interface type. If we look at the class diagram, iterator has a method has methods first, next, is done, current atom, and we have this concrete iterator to inherit that or to implement that interface, and we have this so that we can use this iterator in the concrete aggregate so that we can kind of iterate over every element in the collection. So what's the disadvantage of this iterator pattern? First, the iterator order is fixed by the implementation, not by the client, which basically says your client has no control of the order of your iteration. Another thing is it might be missing various potentially useful operations like addition, set, subtraction, etc., etc. One more thing is the iterator only considers elements present at the time of its creation. So if you change your implementation of your element, your iterator might not work. So in that case, you have to change your iterator again. One more example is decorator pattern. So the definition of decorator pattern is it attaches additional responsibilities to an object dynamically. Decorators provide a flexible way to subclassing for extended functionalities. So the intent of decorator is it can dynamically add behavior to an object instead of using subclass, because we know that subclass has to be implemented at compile time. If we look at the class diagram here, the participants of decorator pattern, first we have the component, which defines the interface for objects that can have responsibilities added dynamically. Second, we have this concrete component, and besides that, we have this decorator. This decorator consists of a component and maintains a reference to a component object and define the interface that conforms to component's interface. And we have this concrete decorator which inherit from this decorator, which will add responsibilities to the component. Right, so what's the disadvantage of this decorator pattern? First, decorators can result in many small objects in our design, and overuse can be complex. For example, if you want to add one more responsibility, one more functionality, you have to add another small piece of code which is the decorator. I mean, if you have many functionalities, you have to implement many decorators that will make your codes hard to organize. Another thing is decorator can cause issues if the client relies heavily on the component's concrete type. This violates the ISP, which is Interface Segregation Principle. One more disadvantage is decorators can complicate the process of instantiation of the component, because you not only have to instantiate the component but wrap it in a number of decorators. If you specifically, if the number of decorators is huge, which will make the instantiation more complicated. One more example is about visitor pattern. The definition of a visitor pattern is to represent an operation to be performed on the elements of an object structure. Visitor lets you define a new operation without changing the classes of the elements on which it operates. First of all, still like the iterator pattern, visitor pattern is interface type. Second, we have to have the element have a accept method which will accept visitor object, and we have this concrete visitor which realizes the visitor interface, and it will have the visit method that visit every element we want to go over. So the programmer has to implement a visit. If we look at this more detailed visit class diagram, we see that in the visitor we have to visit every element. We have like visitor visit the element A, visit element B, etc., etc. So let's look at the disadvantage of this. First of all, adding new concrete element classes is hard because first we need to implement a new method for each concrete visitor class to handle new element, like what I said. Second, if a visitor pattern has not been written in the first time, the hierarchy has to be modified to implement it. Again, it is about the accumulating state because a lot of code has to be rewritten to prepare the use of visitors, even without if-else conditions. Third, it might break encapsulation because visitor may need to access an element's internal state, which could compromise encapsulation. Like if you want to visit some element, we have to know some internal information of that element. So this kind of explosion of internal state might be kind of risky. Let's use an example from class to explain what I mean. Like in our class, we use this shopping cart visitor as our example. So for the visitor, this shopping cart visiting implement the shopping cart visitor, and in this we have to implement the visit method for every element. Like we have to visit book, we have to visit food. If we have drink and food, we have to implement everyone inside this class, even without using if-else conditions. This is still very hard to organize and looks messy. The last example is proxy pattern. The definition of proxy pattern is it provides a surrogate or placeholder for another object to control access to it. The intent of proxy pattern is first, in some case for the object creation or access, it might be pretty expensive, so that we can use proxy, and proxy decides when to perform an expensive operation. Another thing is our proxy allows control access to real objects, so in turn you can add extra functionalities to real object without changing real object code. Well, if we have our client and we have this subject interface, so the proxy is kind of bridge between the client and the real object. So what is the proxy looks like in the real world? A proxy can be defined as a surrogate, like what we talked before. In the real world, a check or a credit card is a proxy for what is in our bank account. Like we can use our check to represent the cash to do some payment, and that's exactly what the proxy pattern does: controls and manage access to the project they are protecting. So how does it work in Java? First, we have to have the common interface. Let me use the image loading as an example. First, we define this image interface, which has a method, it's a display image, and then we have this real image implementation. This real image class implements the image and has a real image method which load up the image, and has the same displaying the image method. And we have another method which is only in the real image class, which is load image. This can handle the resource-intensive operation. After that, we have the proxy image class. This proxy image class still implement image interface and has a proxy image method, and has another method. It's a display image. This method kind of delegate the resource-intensive operation to the real image. So you can see that this display method has a composition of the real image class, and then we use the method from the real image. So what's the disadvantage of this method? The first downside is the magic could be happening that extender is unaware of the proxy trick. For example, if somebody else trying to use your codes, and if he's not aware of the black box problem, which is the proxy, he might have some error or might make some mistakes. And a proxy can mask the life cycle and the state of volatile resources from its client. If a client may call the proxy not realizing that the resource is currently unavailable, in this case, the proxy has to either block until a resource is available again, or it must produce some kind of error. And also, the client may not be aware that the resource it is calling now is not the same resource it called a second ago. Another thing is if a proxy is used to represent a remote resource in the local process, this can disguise the fact that the remote communication is involved. As we know, remote invocation is completely different from local invocation, and our programs should not treat it as if it were the same. It is better if a proxy declares somehow that it is a proxy for remote resource rather than a local resource. Then the clients would be able to choose only local resources or to modify their behavior when using a remote resources. Let me take this as an example. Right, if we have an account which will get the balance method, and when we call this get balance method, and if the get balance method is not ready, or the get balance method change over time, we might get some error. Here comes to our conclusion. First, picking the correct design pattern and understanding how to implement that design pattern to your scenario is very hard. I mean, as we know, in the real life, our project, our problem could be very complicated. First, we have to do the analysis, and then to choose which design pattern or some of the design patterns we're going to use. That's not easy.
And also the design patterns do not lead to direct code reuse. So somehow the design patterns are complicated, so we cannot use the code again.
And the design patterns are kind of look simple, but they're not. and the design patterns have a very steep learning curve, just like how we are suffering in this class now. Thank you very much.
Thank you.